Hi class, in this video what I want to do is a little bit different than some of the previous lectures I've done. So in the previous lectures I've done, I've kind of like followed the textbook and driven off the examples that they've given. But what I want to do in this section here, in this chapter, is I want to just teach you the basics of probability, like just how you calculate them and do a bunch of examples. And so in the coming videos that I'm going to do, what I'm going to do is I'm going to introduce some definitions and stuff and theories and concepts that aren't necessarily in the textbook, but that I think make calculating probabilities easier. And then in some of my later problems, I will answer some of the like Mindscape problems from your homework. Okay, so just start with some basic definitions of probability. So the first thing is in probability we're going to perform an experiment. And what an experiment is, it's an act or process that leads to a single outcome that cannot be predicted with certainty and can be repeated. So what I'm saying with an experiment is it's something that has uncertain results, so you don't know what's going to happen, but that it's immediately repeatable, so you can do the action again. So some examples here are like flipping a coin. This is an experiment in probability because when I flip a coin, I don't know for sure what I'm going to get, but I can repeat it. I can do it again and again and again. Same thing with rolling a die. So when we talk about rolling a die in this class, it'll always be a six-sided die. Or like even drawing a card from a deck of cards. Like when you draw a card at random, you don't know what you're going to get, but you can immediately repeat it. So the next thing, hope you like the sound effect there, is something called, we're going to perform an experiment. So let me go back, perform an experiment of some type. So the next thing is what's called a sample space. So a sample space is a set or list of all possible outcomes for an experiment, and we denote that by S. So here's an example. When you toss a coin, what are the list of all possible outcomes you could get? Well, you could get a head or you could get a tail. So the sample space for tossing a coin is either a head or a tail. For rolling a die, when you roll a six-sided die, well, what are the outcomes here? It's just a 1, or 2, a 3, a 4, a 5, or a 6. So that's just the sample space. It's a list of all the possible outcomes. So what we're going to be doing next is calculating the probability of a specific event. So an event is any subset of a sample space. So we typically denote these like A, B, C, etc. So events we'll just generally denote going forward as some event E. So for example, suppose I'm interested in tossing a head. Well, the number of ways that could happen is you just flip a head. There's only one way out of the two ways it could happen. How about rolling an even number? Well, on a six-sided die, what are the even numbers? 2, 4, and 6. So that event is the set 2, 4, and 6. So now what we can do is talk about some rules before we get into how you compute probabilities. So denote probabilities of an event occurring, such as the following. Flipping heads, we would write the probability. This P here stands for find the probability of getting heads. Or rolling an even number, we'd write this is the probability, P, and then in parentheses what we're looking for. Well, getting an even. So can you have negative probabilities? Obviously not, no. Can you have a probability of something happen more than 100%? Obviously no. So we're always going to show probabilities as decimals between 0 and 1, inclusive. So if something has a probability of 1, that means it happens 100% of the time. If probability is 0, it means it happens 0% of the time or never happens. So what I'm going to show you now is what's called the classical definition for computing probabilities. All right, so let's do an example to illustrate this. So let's roll a die once, because we're going to take a six-sided die and you're going to roll it once. So this is the sample space. This is the list of all the possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, a 6. So the probability then that an event will occur, so the probability of any event, is the number of ways E can happen, so the number of ways that this event can happen, divided by the number of possibilities, the total number of outcomes. So let me show you this in action. So what is the probability that you will roll an even number? Well, so the probability you would roll even. So what goes in the top here is the number of ways that E can occur. Well, there are 3 ways that you can roll an even number. So those are the numbers 2, 4, and 6. And what happens on the bottom is there's 6 total different numbers on the die. That's the total number of elements here in the sample space. So the probability that you roll an even number on a six-sided die is just 3 divided by 6. which obviously simplifies to 1/2 or 0.50. All right, so let's do some more problems here. So we'll do a word problem here. Lawrence is the captain of his track team. The team is deciding on a color, and all 8 members wrote the choice down on equal size cards, so the color they want their outfits to be. If Lawrence picks one card at random, what is the probability that he will pick blue? So if you look here, there are 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 colors that the team wanted to pick. So if you look, there's 1, 2, 3 blue cards in there. So the number of blues that he could pick are 3. The total number of cards is 8. So the probability that he would pick blue is the number of ways it could happen. Well, that's the 1, 2, 3 blue cards divided by 8, the total number of cards here. So if you take 3 divided by 8, you get 0.375. And that would be the probability that he would pick a blue card out of it. All right, let's do this one. So Donald is rolling a number cube labeled 1 to 6. Okay, so rolling a 6-sided die. So what is the probability of the following here? That he rolls an odd number. Okay, so if you look here, the way you can roll an odd number on a 6-sided die is you roll a 1, a 3, or a 5. The solution set is a 1, 2, or the sample space, excuse me, is the numbers 1, 2, 3, 4, 5, and 6. So the probability that they roll an odd number, that Donald rolls an odd number, well, there's 3 odd numbers divided by the 6 total outcomes. That's just 0.50. How about he rolls a number greater than 5? Well, what's the only number on a 6-sided dice greater than 5? Well, that's rolling a 6. So the sample space is still all the outcomes, 1, 2, 3, 4, 5, 6. So the probability that he rolls greater than 5 here, well, it's the number of ways you could roll greater than 5, which is 1, divided by the total number of outcomes, which is 6. So it's just 1 divided by 6, or 0.166, so on. All right, class, I hope that helped. What I'm going to do next is I'm going to put some more lectures on some more advanced problems for you in the next lecture.